Okay, we're going to work on inverse functions today. Just going to do a few examples together. So grab a piece of paper. It says find the inverse of each function, then graph the function and its inverse. The first thing we need to talk about is what does it mean to be an inverse? An inverse of a relation is a set of ordered pairs. The inverse comes when you exchange all of the x coordinates and y coordinates. So, for example, if we have something like a relation which is 1, 2, and then 3, 4, and then 7, 14. If that's a relation, then what we're going to have for its inverse is just interchange the x and y. So I have 2, 1, 4, 3, and 14, 7. Okay? So when we calculate an inverse algebraically, we take the original function, and I'm going to change that f of x into a y. Y equals 2/3 x minus 1, which we all know how to graph, hopefully. All I'm going to do is I'm going to interchange the x coordinate and the y coordinate. So since an inverse is interchanging of the x and y coordinate, all I've done is taken the x and put it where the y is, and the y is put it where the x is, which is exactly what we did on our relation up top. So step one is interchange the x and y's. Switch x and y's. Step two, solve back for the new y. Add 1 to both sides. X plus 1 equals 2/3 y. Multiply both sides by 3 over 2 times 3 over 2. Cancel, cancel. Y equals, distribute, 3 over 2x plus 3 over 2. Step 3, rewrite as f inverse of x. So now instead of a y, I'm going to change this to f inverse. So my f inverse of x is equal to 3 over 2x plus 3 over 2. Now we're going to graph these as well. So if I graph my first line, I go to -1, and I have a slope of 2/3 up 2, right 3, and I have a couple of points there, and I grab a line, and maybe it's this guy right here, and we are gonna go through here. Oops. And there we go. And I'm going to graph the other one. Y equals 3 over 2x plus 3 over 2. So I'm up at 1.5. And if I have a slope of 3 over 2, I can go up 1, 2, 3. And left, or right, 2. Up 1, 2, 3. Right 1, 2. Or down 1, 2, 3. 1, 2, 3. 1, 2, 3. Left 1, 2. And down 1, 2, 3. Left 1, 2. And we have a line.
Hello, everybody.
That's Mr. Nemenich. He wants to talk to you about statistics. So, yes. Okay, back in action here. Mr. Nemenich is gone. Let me try to graph this one again. Okay, so when I run this graph through here, and if I run the other one through there nicely as well, Let me get rid of that. So that was through, where was that through? It's going to be through here. I'm going to run through there. When I graph the two lines, when you graph a function and its inverse, they will be a reflection over the line y equals x. Because what do you know about y equals x? The line y equals x is going to be this guy right here, and that's when the x coordinates are equal to the y coordinates. And if you think about what I originally said, find the inverse of the function with the relations, the ordered pairs at the top, interchanging the x and the y's. Like, for example, this 0, 1.5 right here. This 0, 1.5 right here shows up right here at 1.5, 0. And this point that they're passing through down here is going to be negative 1, 2, 3, negative 1, 2, 3. That's going to satisfy both of the equations, the inverse and the actual function we started with. Let's try another one. Start by changing it into a y. Next, interchange the x's and y's. Next, solve back. Divide everything by 2. And rewrite in inverse form, which is read f inverse of x equals 1/2 x plus 3 over 2. Go over here and graph them. Graph this guy, y-intercept of negative 3, slope of 2, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Grab my straight edge. Comes through like that. Pretty good. Next guy, I got 1.5 again, 3 over 2. To get back on, I got a slope of 1/2. So I can go up 1/2, right 1 will get me there. Now I can apply my slope, up 1, right 2, up 1, right 2. And down here I go 1/2, I can end up there, down 1, left 2. Okay, so when I grab my straight edge here, straight edge and green guy, great. And now when I run through this way, there's my other graph of my inverse. And if you think about where is the line y equals x, we said that should be here, coming through there, and we are set. The purple guy was the original. The green guy is my inverse. The black guy is the line y equals x, and a function and its inverse will always be reflected over the line y equals x, because the idea is all of the x coordinates are interchanged with the y coordinates, and we are good to go. Determine whether each pair of functions are inverse functions, right? Yes or no. In order to determine whether the functions are inverse functions, here's what you do. If f and g are inverses, then f of g of x, remember Fogg, will equal x, and g of f of x, Goff, will equal x. You need to show your work for this. So what we're looking for is f of g of x equals x, and g of f of x, equals x. So we're going to plug these in. F of g of x, we'll put the g function into the f function, 1/4 times 4x minus 20 plus 5. Distribute the 1/4, x minus 5 plus 5, and I get x. we're looking good for being inverses of one another. First half is complete. Second half, we'll run g of f of x will be equal to the f function will go right here. 4 times 1/4 x plus 5 minus 20. And we will go with x plus 20 minus 20 is x. Must show your work. G of f of x is equal to x. Yes, they are inverses. Whenever, if you get one that's not equal to that, you've either made a mistake or they're not inverses. Same thing here. Let's plug it in. Start with f of g of x. Put the g function into the f function. I'm putting this one in there. I got 1/2 times 2x plus 1/10 minus 10. Distribute the 1/2. X plus 1/20 minus 10 equals x. 1/20 minus 200/20 is negative 199/20. We did not get x. These are not inverses. I don't even have to check the other one. I should check my work and make sure I didn't make a mistake, and we can move on. And the last one, check to see if they are inverses. F of g of x is equal to 2 times 5x plus 2 plus 5. You'll get the hang of being able to recognize if this is going to be feasible, and clearly this is not inverses. Okay, so you got your two types of problems. One is showing their inverses and graphing them, and the other one is checking the fog and the GOF to see if they work out. Enjoy.